Risk assessment and analysis. So we saw what is the risk assessment, what is the activity. It is a process of assessing the risk to the people's safety and health from the workplace hazards. What is the hazard? When we talk about hazard, is nothing but a situation or act with the potential for harm in terms of human injury or ill health or damage to the property or a combination of this. Whereas what is the risk? Risk is nothing but a combination of likelihood of occurrence of hazardous event or exposure or severity of injury or ill health that can be caused by the event or exposure. So we have seen the example like lion out of his cage is actually a hazardous situation. But what is the risk around this because of this hazardous situation? Injury to the people or person can be killed, okay, got killed, kind of thing. So how do we minimize this risk, or how do you reduce this kind of risk? Okay. So what is an emergency? An emergency is a situation that poses an immediate risk to the health, life, property, or environment. An unforeseen combination of the circumstances or resulting state that calls for immediate action. So in case of emergency, where the situation can possess immediate risk to the health, life, property, or environment, which requires immediate action. So, in case the lion is out, is a hazardous situation. What is the risk involved to it? Injury or kill, person getting killed because of the lion being out. So, what is the immediate situation? This is an emergency situation. What we should do during this emergency? We should try how we can contain that lion. Okay, how do we capture that lion, put it back into the cage, or probably take him and release him in the forest area or kind of thing, or where it is not could cause any kind of injury or kill. Like a lot of time, uh, wildlife animals, they cross border or the boundary of the forest area and all the things, and they try to come near to the people where they are staying and all the things. They also happen, honey, or even in Borivali, those locations. Similarly, when you are talking about drone, you could have an emergency. There could be an emergency related to fire, medical, environment, or technical issues also. So we should see how, if any kind of this emergency could appear, we can see how we can reduce it or mitigate. So we should envision this risk and then have an emergency plan. As I said, when you could have a fire, you could have a medical, you could have environment, you could have human or technical also. So you should have an emergency plan with respect to this kind of stuff. Okay, so emergency plan specifies the procedure for handling sudden or unexpected. All of a sudden there is a fire in the resort. What will you do if you do not have a fire extinguisher or any provision to contain that fire? It will cause more damage, right? So if you have an emergency plan in that scenario, then only you will able to contain it or you will able to control it. Like for example, in our office, we have all these fire sensors been put. We have all these hose where automatically after certain period of fire, it will start sprinkling the water and all that thing. Or we could have extinguishers kept in the office at certain places, so that if there is a small fire, we should able to contain at that point in time. If you are not able to contain, if you do not have a fire extinguisher and you can't control it, then it will spread more and it will cause more damage. That's how we should able to have plan for handling the emergency. Like in our office also we have a medical kit in case somebody is not feeling well or some problem occurs or something happens, some small minor accident happens, somebody has having a cut while doing something or other thing. If you are able to control that, take care of that injury and all the things, it will further reduce the further challenges or further risk happening to that person. Okay. Similarly, some human while sitting in the office, he may be in a good condition when he had reached to the office, but for the period time because of some bad food or due to something eating or due to something anything, it could be anything. The person may not feel well or something. So we will try to see what the best we can do. Or in case that person is not able to feel better after even by taking a rest or having water or whatever it is, we may have an emergency plan where we may have contact of a doctor. So we should contact the doctor and ask him to visit the office and see what is what. Once the doctor visit immediately, Imagine if these things are not there with us. What would happen? We will be searching around which doctor to call, where to take, what to happen, all that kind of stuff. Or any kind of problem happens. A lot of times, some problems which happens like we do not know what is to be done. If we do not plan for emergency, then we cannot reduce or mitigate the challenges what we encountered during the emergency. So let's see now what kind of emergency situation can have in drones with respect to the drone. So first emergency situation in drone could be the loss of communication or loss of control link. In that scenario, what could happen? ARPAs crash into one or more buildings. Let's say you're flying, you're doing pitch forward, and all of a sudden you lose the control from the drone. You're no longer your remote is able to control the drone. In that scenario, what will happen? It will continue moving forward, and it may crash. Either it will make the tree, it may be crashed in the building, or whatever come in between, or it may fall on somebody after some time. It could cause those injury to humans, or the debris, or the building could get damaged. Anything could happen. So these are the possible effect of this kind of emergency: loss of communication or controlling. But what you can do in this scenario, because every time what happens, when your drone is flying, it is always sending the inputs back or control back to the your remote. Okay, so there is a continuous communication handshake is happening between the drone and the remote. Okay, the moment drone software, okay, the flight controller knows that it is not able to get the signal or inputs from the RC. It knows that it has lost the control with the RC. So it will know that it is no longer in control of the RC. So there is an algorithm written into the flight controller in such a way that it will trigger. I mean, it will try a couple of times, trying to whether it is receiving a signal from RC or not, and all that things. Okay, if it is not receiving, it is not able to get communication or handshake from the RC, it will trigger the option called Smart Return to Home. That is RTH, where aircraft will return at a safe altitude. Okay, so it will safely land the, the drone from where it was launched or from the home location. So this is setting what is being done called as the communication failsafe. That is FS hyphen form setting. This feature is available to counter this type of emergency. I mean, I can put this FS form situation in the drone, so that let's say after a period of 5 seconds or 10 seconds, if I'm not able to get the signal from the drone, from the RC, it will trigger the RTH. Okay, clear on this?
Yes, sir. Yes, sir.
Okay, let's see the next. Next is a lot of time when you are flying, your aircraft will just keep on flying. Okay, I give a throttle, or I will give a let's say I give a pitch forward motion. Okay, so in that scenario, your sometimes all of a sudden your drone will continue flying forward. Okay, and it will go, it may crash, or it may hit somebody, or it may get stuck up into the what we called any kind of obstacle. It could be a tree, it could be a power line wires, or anything. Okay, so in that scenario, what will happen? How do you control this kind of situation? Just a minute, I'm getting a call from office. Okay, sorry, I got a call from the office. Okay, so in case of geofencing, sorry, not geofencing, aircraft flyaway, what would happen if suddenly you do not have any restrictions? What will happen? It will continue to go forward, forward, forward. You are not able to bring it back, or you are not able to control the car speed. What will happen? It could crash into any kind of obstacle it comes into. It could be crash with the another road, or it could crash with the manned aircraft also, or it could crash into the building or obstacles, and that crash could, the crash debris could be hitting people on the ground also. How severely the thing have, like, you have seen collision of the aircraft with the World Trade Center. Like they have crashed the aeroplane into the building. Entire World Tower was destroyed. Okay, so we do not know because the drone would be flying at a very high speed and all. So what kind of damage to that? So just to restrict this flyaway situation, government of India has very made clearly that as per the drone rules, you need to have a geofencing configured in your drones. Okay? So once you have a geofencing configured, your drone will not fly outside that zone, or it will never go outside that zone. The moment you reach geofencing area, okay, your drone will trigger the RTL. Okay, so it will go come back and it will land. Okay, so geofencing is always enabled and does not allow pilot to fly outside the defined curve. I mean, you can define how you want. Like if you just may want to make sure that it gives you alert that you are going outside and it will not, the drone will not fly beyond that virtual boundary. Okay, you can do that. Or normally we configure in such a way that in case by mistake you cross, you try to cross the geofencing boundary, your drone should land. It should do have a RTL kind of thing. So we normally keep it in that way so that it's safely, because sometimes people do not know what they are doing and they'll just give the control on the RC and drone will go fly away or something like that. So just to avoid that scenario, we will have a geofencing configured with RTL procedure so that it lands. Okay. Then all of a sudden you are flying the drone, your battery power loss or failure could also happen. It could always have, because end of the day it's a equipment, okay, and it's flying. So you could have in that scenario, if your loss of power, let's say loss of power means what, your drone is under beyond your control. Okay, in that scenario you could not do anything. Okay, because the motor will stop working. You will definitely have a crash. So you could have a crash landing situation in that. But could be something could be done so that battery, if there is a failure in a battery or something like that, or loss of power, like a lot of time, we normally fly with 100% battery charge, and we are advised to fly only up to 50% of our battery. Okay, so we should always fly within that range. Once we are 50%, we should always keep buffer. Okay, people are tendency, like people to go very beyond, like people will go 10%, or they may fly up to 20% and 10%, and then they are not, sometimes drone is not able to comprehend all your uh, flying, or not able to take the commands, or not able to come very from the far off and all. Just Okay, sorry, we were getting the delivery of the notebooks for you. That person was actually calling me.
Okay, okay, sir.
So think about the battery loss. Okay, sometimes people, we always configured something called as FS-BAT or battery failsafe mechanism. So if my battery failsafe mechanism is configured for let's say 40%, so I should not go up to 40%. Before that only I should land my drone. So if it is configured for 40%, I should land my drone somewhere around 50%. Okay, if I do not follow that procedure, what will happen because of the failsafe battery configuration? Immediately as it reaches that threshold, my drone will either initiate RTH or will initiate RTH. So that will be configured. So just to safeguard that I am not overutilizing my battery. Okay, so in a drone, it is configured FS BAT as a configuration where if the battery voltage is less than 21.2 volt, switch to RTL. So moment you reach this particular voltage, it will switch automatically to RTL so that it will not wait for a pilot to see and monitor and do it. But we should never wait for RTL to get triggered. If we know that it is reaching 21.5 or something, we should stop and we should land our drone and change the batteries. Okay, this is only in a safety feature. Safety feature is there, but we should never make sure we should let that that safety feature get triggered. So that means we are not following this proper procedures or we are not following the way we are actually the SOPs are written for flying the safe flying. Okay. So just to avoid a battery power loss or a failure around that scenario, we'll always like even let's say I can configure batteries FS bat to 10% of the battery level also. So I can consume the battery till 10%, but the moment it goes up to 10%, it will trigger that. So that is how I am not seeing that my battery like we have a tendency. If you see human tendency, lot of time हम लोग देखते मोबाइल यूज करते देखते ओके अभी कितना मेरा बैटरी है 10% हो गया. Okay. But we don't charge. Okay, or we don't get up and let's say, okay, sometimes we do it, but sometimes we say, ठीक है अभी 5-10% है ना. Okay, I'll wait for 5%. We keep on doing it. Okay, if you are get engrossed into that activity, and then all of a sudden your phone dies. Have you encountered this kind of problem or this kind of scenario? Lot of time
Yes,
happens with us, right? Lot of time. In the
yes, sir.
night में also हम लोग कभी कभी मोबाइल पे कुछ we are seeing something or watching movie or just simply scrolling on the mobile. Lot of time we reach 10%. बोला ठीक है 10% अभी है. We'll think that 10% is there. Let's continue. And we do not know how that 10% will get consumed. Okay, all of a sudden your mobile, then you realize, oh, it was 10%. I should have put charging. Then we will immediately get up and that. But this cannot be taken into the drone, right? I cannot say, okay, 10% hai, abhi time hai, I can, I'll do after 5% or maybe after some time. You can't do that. You can't take the chance in a drone. So you always have to configure minimum whatever safe is there. So in a drone, this thing people normally configure. It depends again, drone to drone, and how you want to, how efficiently you want to do it. You can consume battery up to 25% also, and remove the battery and charge because again, your charging time of the battery will increase because you are discharging the battery at a very high rate. You are discharging almost to 25%. That means 75% of utilization has happened, and then you are going for a charge. Okay. So ideally, standard practice people follow across in the drone industry is that they um, 50-40% normally they will keep as a fail-safe mechanism, and then they will get the drone to be landing. So in our training scenario, we'll always land a drone when we reach 50%. Okay.
Okay, sir.
Sometimes you may have get the this is similar to your remote control. Similarly, your RPAS, your what we called control or GCS, okay, ground control station, not able to communicate with the drone. So RPAS lose of the control. So it could be undesired flight trajectory. cause mid-air collision with other aircrafts or manned aircraft. Landing could cause serious injury to many person or ground and possibly fatalities. Okay, these are the cause for effects of your ARPA's loss of control. What is the contingency plan? Contingency plan could be stabilization and position hold based on the GPS and INS reduced on any uncontrolled risk. So your drone can be configured in such a way that in case of ARPA's loss has happened, the drone could go into a stabilization mode or could go into the position hold kind of scenario. Okay, so what happens at a particular, if it is not able to communicate with the GCS, the drone will continue, but it will not move from that particular position. It will go into the such a mode that it will keep on hovering at one particular till the GCS is. Imagine your GCS is not able to control. What will happen? Continue flying at a particular on a position hold. Continue flying at over a period of time. What will happen? The battery will get consumed. You will reach the threshold. After reaching the threshold, what would happen?
It will stop working and get crashed.
No. We've seen the earlier option, right? What happened here?
Oh, uh, R- RTH.
RTL or RTH would happen, right? Return to home or return to launch. Okay, both are some or less same point. Like wherever you start your drone, that is your home position, or from wherever you take off the drone, that is the launch position. So more or less both are the same. Okay? Either it can happen RTH or RTL. So a lot of people configure RTH different and RTL different. Okay, so for example, मैंने एक जगह पे रखा ड्रोन और वहां पे मैंने पावर ऑन किया. Okay, so that power on, when the moment you power on, that point where it is powered on, that is your home position. A lot of people, they do the power on at one portion and then they move the drone, they pick up the drone and put it at some other location from where they intend to do the flight. So then, you will have a RTH where you have powered on the drone, but you have a different RTL location because you are take off a drone from other location. So in that scenario, you have a two different points. Like RTH would be different and RTL would be different. But if you are powering the drone at one location and from same location you are launching, so your RTH and RTL will remain same. Clear?
Yes, sir. Yes, sir.
So in case of this, because of the your battery getting over, you could have RTL. But in case pilot could take a manual control to recover the UAE, so if he could using the remote instead of GCS or RPAS, okay, if he is able to take the control through the remote and manually try to move the drone from one position to another position or probably land it safely, okay, so that could also be possible. So a lot of time you would be having an unsuccessful landing or flight termination. Okay, so vehicle breakup or totaling, road crash fire that injures ground crew, threatens wildlife environment. Our pass collides with the building, bridges, other obstacles, causing debris that injures or cause fatalities on the ground. Okay, so because of these different scenarios you could have, but what could be the contingency plan to have such kind of? I mean, you could have an unsuccessful landing. If you have an unsuccessful landing, you do not have any contingency plan for it. Okay? So return to home is always active, thereby preventing aircraft from landing outside the defined area. So a lot of time we try to initiate a landing, manual landing or some kind of a landing at a different location. So if you have configured in a such a way that the drone has to land only on a particular location only, that is a smart return to home. So I will always trigger or I will always have a configuration that the wherever I want to land, whenever I want to land the drone, it should always follow my smart return to home functionality. Okay. I can always trigger it from my control. I can always switch the return to home. I can press that return to home button and then automatically my drone will land at the RTH location. Okay, sometimes your drone. So right now, these things are not very, very often or very possibility of these things. But in near future this could be possibility that somebody takes the control because you are flying the drone on 2.4 gigahertz. Okay, so somebody can take the control. But now in certified drones, your RC and your flight controllers are also binded by some mechanism. Okay, there is some software configuration is being done so that any other remote could not take the control of your drone. Imagine it is an open standard, like you do not have any binding with respect to the RC and the flight controller. Then I can bring any other remote controllers, and that remote control will also, you will be able to control your drone. So that is your hostile remote takeover or the control of RPAS. So to avoid this, we'll always have anti-tampering measures have been implemented. That means nobody can take the control or can get inside your drone or do any hacking kind of activity. So hardware is detected by the only specific proprietary software and accessible only on the machine installed with the drivers. Okay, so they have something called a key mechanism. Okay, so there would be a safe key between the laptop which is used for configuring the tool. So most of the time, as a vendor, not as a vendor, as a user or a consumer of the drone, we may not be having access. Okay, so that is basically this kind of access would be available only with the OEMs. Okay, so they will be having access to the hardware through their laptops or their configuration machine only, and they have a key. So normally those keys are not given to the consumer or so when if they wanted to do anything on the hardware part, they will ask you either bring the drone to me or they will come to your place with the laptop. Okay? Again, the software interface used for firmware access is protected by password. So even though there is a C-type connector, you can just connect the C-type connector and take the access. But every type further activity you need to perform on that particular device, it will ask for a password. Okay, without entering that password, you will not able to upgrade, downgrade, or whatever is required related to software activities. You will not be able to perform. Okay. Again, these user passwords and all the things are not shared with the consumers or the users. Okay, they are normally kept with the OEMs. Okay, only in scenario like RPTO, since we are RPTO and we are actually imparting training and all the things, the username and password is shared to us. But normally, like let's say a farmer who is purchasing an agribot drone, they will not have access to all these kind of things. Okay. So what is threat and error management? Threat and error management is an overreaching safety concept regarding aviation operations and human performance. The threat and error management framework is a conceptual model. See, as of now, there is no really what we say. People have not worked on these topics. Okay, these are very at a very conceptual stage as of now, because until unless we have that kind of environment, like even today, whatever we see, all the rules, regulations, everything into the aviation, it is over the period of almost like last 124 years, okay, or I would say 120 years. After that only we had all this thing. Whereas our drone industry is just hardly 3 years old. Okay, or if you see from the ICAO standards, it is just like 2015 still 2025, almost 10 years old. But it was not adopted by any countries so effectively. Okay, though from ICAO standards, 10 years have been passed, but from India perspective, we are just 3 years old into the drone industry. So these are not so uh, tested or studied kind of subjects. Okay, now people are trying to see that these are very what we say important with respect to the safety, security, and from with respect to human performance because of the dynamic and challenging operational context. So every field wherever you're trying to fly a drone, agriculture field you are flying to fly a drone, there will be its own challenges. When you are flying in a power line towers or for a telecom towers or in windmill or a solar panel farms, different farms, or even in your context where you are saying that you are going to fly a drone within the ship. Okay, so every ship internal structure would be unique. Okay, we do not know how it is going to be. There could be obstacles in between and what kind and all the things. So in that scenario, we need to see how uh, the safety securely, and even from a human performance perspective, how are we going to fly the drone in that scenario safely? Those are the things what we need to understand. So there are three basic components in the 10 frameworks: is the threats, then errors, and then undesirable aircraft states. That means we've seen, with respect to the drone, there were a lot of undesirable states like GPS loss or remote control loss or battery failure or all that thing. So what could be these? What are the threats could have generally defined an event and occur that occurs beyond the influence of person, increase operational complexity, and which may be managed to maintain the margin of safety. Whereas errors are generally defined as an action or inaction by a person that leads to deviation from the organization or operational intentions or expectations. Sometimes, we take, we become overconfident. I will try to, like, I have seen one of my pilot when he was actually doing surveillance for power line towers. When he was shooting the video, he because he loves shooting video and taking the drone, in the circle and all that kind of thing. So one time he was just flying it, and since when you are flying the drone in a circle pattern, actually when you are flying the drone in a square pattern or rectangle pattern, that time you are only giving control from one joystick. But when you are flying a drone in a circle pattern, you are actually giving pitch forward as well as you are doing the yaw motion also. So two controls at the same time. The moment you tried to give too much of yaw or too much of pitch, your drone cannot form a proper circle. It can go like हम driving करते वक्त अगर accelerator भी मैंने ज़्यादा दबाया, and if I don't turn the wheel also properly, either it can go straight or it can have a big turn, so depending upon, so मैं speed में भी आ रहा हूँ और I am also trying to turn my vehicle by angle. That point in time, possibility of the car might getting upside down is a possibility is there. So similarly in drone also, whenever we try to do two motions at the same time, possibility of me flying in a wrong direction could be possible. So, so when my pilot was doing that activity, all of a sudden the drone went very close to the tower. Okay, he was almost was about to crash into the power lines. Okay, which was very very dangerous or hazardous. So these are errors. Okay, intentionally or could also unintentionally could also. And then it could have we could also have undesired states. What we talk. Okay, like we talked about battery failures. Or could be like when we are flying a drone, it was very initial stage. We were flying DJI Mavic drone, and the pilot took the drone very close to the power line. And since the power line are having the magnetic induction also in those, and the Mavic DJI is not meant for this kind of service. Okay, so it was behaving very weirdly after that. I don't know what had happened. So we after that it was not in a proper flying condition. Something would have had happened on the sensors and all that thing, because there are obstacle sensors which actually get the signals and all the things, and they were not functioning properly, so it was not able to detect the obstacles or all things. So we were in a situation where we have to discard that drone from the further or future operations. So after that, we tried to use that drone for other things, but it was not going properly. So we sent to one of the person who was actually repairing DJI drones. So he said that probably you may have to. I mean, we told him what has happened and all the things. So based on that, he said probably then you would have to change the obstacle sensors of your drone. But then he was not sure whether there was a problem with the obstacle sensors or there was a problem with the flight controller. So he was also suggesting that you can change the complete entire board of that drone. So anyway, that board was not available in India, so we could not do anything into that. And again, changing the obstacle sensor was also very expensive. So we said rather doing all these things, we will purchase a new drone rather spending money on this thing. So we discarded that drone because we can't take a chance of drone getting crashed into the power line towers and all. It will become major issue. Okay? Like if you crash your drone into the power line tower and if there is a outage or anything, I mean it will a big activity in itself. Imagine आपका wire cut हो गया, टूट गया and all that things, power line tower cut हो गया, it will impact a huge area and it will be a lot of issues would be there. So a lot of time these people on board power boards would always warn us that whatever you are doing, you are responsible for your action. The board will not come into picture. Board has only given you the order contract, but all actions will be your responsibility. That is what they would take us from us writing. So we are taking that risk. Okay. So when we are taking that risk, we are seeing that we will not do something extraordinary or adventurous kind of flying. Okay, so we would always tell our pilots, and that's why we will always have two people, doing the activities at that point in time. Okay, see, there are some situations which is beyond your control. So pilot, human performance, what we call, you pilot pagal hi ho gaya, I mean, he goes mad and he crashes the drone into the power line tower, then you can't help it out. Right? It's all human purpose error or kind of thing. So that's about the threat and the error management topic. What are the emergency identification? It could be pilot error, could be because of the heavy wind, could be the loss of altitude because of the IMU failure. There could be a remote controller failure, that is RC failure. There could be a compass failure. So compass failure हो जाएगा तो क्या होगा? The drone will not know which is orientation. It will not know north, south, and east and west. Then you could have motor or propeller damages, or you could have a medical emergency. The pilot may not be killed, or all of a sudden he's having some medical emergency. That's scenario. You need to understand how we can handle this kind of emergency. Okay,
Yes.
that we complete. So now we have two topics. Uh, One is the payload installation utilization. Do that now. This we have a topic called